Okay, we're given a sphere of radius 4 centered at the origin, written kind of badly up here, but it's on your document, and a point x star, y star in the xy plane. And we were asked what's the condition on x star and y star so that it would be inside the sphere. And we had a lot of trouble answering this question. So we had to spend a lot of class time, 10 minutes or more, answering what could be said about x star and y star. And some of the suggestions I got, one was something about 4-4 is not, about 4-4, okay? And it's a little bit vague, but the assertion seemed to be that the point 4-4 would be inside the sphere. And that's not the case. The point 4-4 isn't inside the sphere. What's the condition for something to be inside the sphere? Well, the sphere has radius 4 and is centered at the origin. The sphere consists of all the points that are 4 units away from the origin. The distance from the origin to a point on the sphere has to be 4. And every point whose distance from the origin is 4 will be on the sphere. And every point whose distance is less than 4, distance from the origin is less than 4, will be inside the sphere. Well, the point 4-4 is not at distance 4 from the center of the sphere. It's at distance 4 times the square root of 2 from the center of the sphere. Distance from the center of the sphere out to point xy is square root of x squared plus y squared. Clearly, this isn't the case. Okay, so that didn't, that answer didn't satisfy the test of whether a point is inside the sphere or not. Now, the instinct there was something about 4 being the radius of the sphere, and there's something about 4 that was going to be a criterion for this point x star, y star to be within the sphere, but that's not it. And another suggestion, somebody said, well, 4-4 is greater than 4. Now, there's a big question mark on that statement, but I think the intent of that statement would be that the point 4-4 is more than 4 units from the origin. So I think that that was a well-motivated statement with the right idea. But I just want to point out that the flaw in that statement is that the ordered pair 4-4 can't be said to be greater than 4 because the ordered pair is not a number. Only numbers can be greater than 4. Okay? A point can't be greater than 4. Now again, the impulse was there, it's further than that from the origin, further than 4 from the origin. That's good. But you want to be careful to phrase things in a way that's, well posed, okay? And that's not a well posed statement. You get a lot further in trying to solve an unfamiliar problem if you make sure all your statements are well posed, because that avoids the vagueness that we can run into here, in the vagueness in how you would actually determine that that's really further than 4 units from the origin. And of course the way is just the Pythagorean theorem. And I'm saying, unfortunately, a lot of unfamiliarity with the application of the Pythagorean theorem to points in the plane, and to the geometry of the plane. And this is something that should have been developed starting in algebra class. And it's certainly developed well in a pre-calculus class, and in trigonometry. Lots of places it should be developed. So make sure you've got those relationships. You can do it, but it's a hump when you're trying to understand multiple integration and the integral theorems. You don't want to be hung up on that. And unfortunately, people are to an extent. We expect people will be to an extent, but probably not to the extent that we're seeing. So be sure that you grab onto this and really understand this well. Okay, so the criterion for x star, y star to be inside the sphere, where x star, y star are the coordinates of the point in the plane, the x and y coordinates of a point in the plane is simply that the square root of x squared plus x star squared plus y star squared be less than 4. Then it's inside the sphere. If it was equal to 4, it'd be on the sphere. And another way to say the same thing is just x star squared plus y star squared is less than 16. Obvious relation to what we have here. Okay, so that's the first question, and that was a big hump, so I'm going to stop this video here and move on in the next video.